Hello and welcome to this short video. I am Hussein, and for now we are going to continue our article that explain the impact of a proportional controller to handle a level of tank. Okay, that is our code, that is our blog that we have discussed in the article, and for now we are going to explain practically how the proportional gain value affect on the system response. Okay, here we have the filling valve, as we said, the discharging valve, the LT, that provide us with the process value. Here we will display the process value, and here we are going to display the desired tank value, or the set value, or the operator for the operator. Okay, sorry. Here is this potentiometer to adjusting the set value of the tank, of the level of the tank, and here the proportional gain value. By changing this potentiometer, we will adjust the value of the proportional gain. Okay, we will discuss three cases. Okay, the first one is a low value of a proportional gain. The second case for a high value of a proportional gain, and the third one, it's a mid value between the low and high values. And we will check and we will see what will happen. Okay, let's check that we are connected. Okay, start, standing up. Okay, pressing start and adjusting the desired tank level to be 3.7, and as we can see, there is no any change because our proportional gain is equal to 0. Here 0, so the control signal also will be 0. Okay, let's adjust this one to be a very low value. Okay, let's check here, it's 1.6. okay, and we are going to see how could the system respond with that. What is the system response for a low value of a proportional gain? Here we can see that the process value of the tank trying to catch the desired value. We can wait and wait. Here is the process value, here is the desired value. The process value is really very slow, and system response to fill the tank is really slow. And here is the result of our first case. We can notice that with a low value of a proportional gain, we will get a low and slow response of the system. We can wait maybe 2 and 5 minutes for the process value to catch the set value, and that is totally unacceptable for a planet. Okay, that's too much time. So let's change the desired tank level. Okay, and trying to increase the proportional gain to be the maximum. Okay, let's try the maximum value of a proportional gain, which is 10, and let's check what will happen. I think the system response will be as fast as possible because we increased the proportional gain to the maximum value. But on the other hand, we will catch another problem, we will face another problem. As we will see, the process value is trying to catch the desired value as fast as possible. Yeah, it's really quickly. Here is, and it's done. The process value reaches to the desired value, but as we notice, there's a little of overshooting. The process value not just reaches to the desired value, it exceeds the desired value also. And for now, the process value trying to staple into the desired value. It's now kind of oscillating about the desired value, which is called system unstable. So for the second case, we will get with the high proportional gain value system instability. If we wait for just 30 seconds, we can here we can see that the system is totally unstable. We can look to the level of the water, it's oscillating because of a high value of a proportional gain, and that is also 100% unacceptable. So for this instability, let's try to change the tank level again, and let's try with a mid value of a proportional gain. It's to know it will be so small. Okay, let's increase it a little bit. Here it's 5.2. okay, that's a good value. It's the mid of the high and the low value of proportional gain, and we can see that the process value in its way to catch the desired value. Here it's increasing and it's increasing. It's really a good speed. It's not the maximum speed, but it's really a good speed, and we can see that, and that is our target from the article. We can see that the process value smoothly, and be aware of that word, smoothly reaches to the desired value with a reason, with a good speed of the system, with a very good behavior of the system without any instability. For a mid value of a proportional gain, the system is really slightly speed and slightly fast, and don't have any overshoot. So, and let's summarize what we were saying. For a low value of a proportional gain, we will get a very slow and a very dying system response. For a high value of proportional gain, sorry, we will get a fast response, and it may be no time for the process value to catch the desired value, but on the other hand, we will get system instability. The best thing is the third case, that we have a mid value of a proportional gain that will give us a very good fast response. It will give us good response of the system, not slow, not fast, but it will be really good, and smoothing behavior. That's the important thing of a proportional controller, is the smoothing behavior. So That's it for now. I hope that you got the idea, and see you soon. Bye.